We are almost finished with this problem. We're on step 8. We've already integrated use of 1 prime to find use of 1. Now we're going to integrate use of 2 prime to find use of 2. So, use of 2 prime was inverse tan of x. And I'm going to use parts again. U is inverse tan of x. And the derivative of that is 1 over x squared plus 1. That leaves dv to be just dx. And the integral of dv, that's just going to give me x. So this next line is where you write uv minus the integral of v du. uv, that's x inverse tan x minus uv minus integral of v du. v du, that's going to give you, multiply that by x. You get x over x squared plus 1. Now we need to integrate this thing. And this is close to being du over u. The denominator is x squared plus 1. What is the derivative of x squared plus 1? It's 2x. Notice I have an x in the numerator, but I need a 2. So on the next line, I've put a 2 in, but I've got to counteract that by bringing a 1/2 outside. So this next line, x inverse tan x minus, this is du over u, so it's ln of x squared plus 1. X squared plus 1 is always positive, so I did not put any absolute value bars. So my y sub p takes on the form u sub 1 e the x plus u sub 2 x e the x. Do you remember where these come from? They come from your y sub c, the variable part of your y sub c. So here I plugged in what u sub 1 is, times e of x. And I plugged in what u sub 2 is, times x e the x. And what I should do now is simplify y sub p. Multiply both of these by e the x. Multiply both of these by x e the x. And just try to simplify as much as possible. I didn't do that here, but that would be the next step. So my final answer is y equals y sub c plus y sub p. This is y sub c. And this is y sub p. Here, oops, I didn't mean to do that. So there it is, y sub c plus y sub p.